Hi, in this video we are going to have a general discussion about walls and how they work. So what I will do is I will go to our brickwork view. And then also go to the brickwork toolset. As you can see, we have the wall tool, plus some other tools for snaps, for our two-wall space, wall types, plus an items tool, plus a splitter tool, which comes in handy. But we're going to talk about walls, so what I will do is I'll draw one into our model. When we use the wall tool, you'll notice that this wall style option pops up. So if we drop that list down, we can actually see what wall types you get as part of the template. And I've organised the structure into one course face, two course face, build up. So if we go to one course face, you can see all different wall types we have there, two course face, any build ups, and any rendered walls. And any internal brickwork or wall types, I keep at this top level. Okay, so the walls have a naming convention. So if I go to two course face, reduce that list a bit, we'll see that a common wall type that we use is our standard two course face cavity wall with verticals or vertically cored wall brickwork and detailing. So that wall that we have highlighted there, just to explain the naming convention, we start with wall 230. So that's the width of the wall, not including any plaster or render finishes. So that 230 is given by the two course face, which is 90, the vertically cored internal, which is 90, plus the 50mm cavity. But you can see the actual naming convention continues on with two course /CA/VA/PL. So we have shorthand terms for the components that build up that wall. So in this case, two course means two course face, CA means cavity, VE means vertically cored, and PL means plaster. And so that defines the components of the wall for your reference. So if you look at some of these other wall types, we have one here which is very similar. The only difference is the cavity is now CI, which stands for cavity insulation. So if you want to take wants for insulation, you would use this wall instead. So just other types here as well, like a stock standard two course face with no finishes either side. We have, for example, here two course face with plaster on one side, and that's used in the case where you have a two course face wall, one side's into the garage, the other side's of the house. And similarly, you have your two course /render, that's RE, stands for render. So this is where you would have a rendered side wall for your garage, for example, or a rear passage wall at the back. And if we look at some of the other types, we have, so we'll jump over to rendered, which is another common wall type we use. So this is just wall 230, render, vertical, cavity, vertical, and plaster. Okay, so that is the naming convention. And if you remember that settings object we looked back in the settings object video, that gave you a full list of the components that you can look at and use and understand. All right, for now, I'm going to select this common wall and I'm going to draw it in this model. So in this case, we're just going to quickly draw a wall and have a look at it. So click a point to start and then double click and the wall is complete. And to stop drawing, you just press escape. So there's a wall. Okay, and there's the style that we used. That's the layer it's on, very important it's on that layer, so it gets the correct height. And there's the glass that's on. Okay, so you can see it's picked up the story height or the layer height. If we want to make that any higher, we can put in 172. So there'll be two courses higher than the story. If we want to drop that down, so for any particular reason, that might go down to a drop footing, for example. That would be now two courses lower. So if we look at that 3D, Spin this around. You can see that's how this wall has actually been defined. So you can see, by definition, this cavity wall, the two-course face is automatically dropped down 3 courses to allow for our eaves, and it drops down 2 courses to drop down to the footing. And this internal leaf always refers to the ceiling height. And again, the cavity goes with it. So quite a simple concept. So if we start changing some of these heights, you can see what happens now. So if we change the bottom offset back to 0, you'll see that's picked up as 2 courses. And if we want to make that higher, you can actually type into this box to make this 2572. Or you can type in 0 there, give you the same result. Now, if we want to change these component heights, so for example, we want to move or change this component, this two-course face component, to be the same height as the wall height, this is what we can do. Select the wall and go to Components. Now we can start to see some more information on how this wall is actually created. So I'll bring this all the way across. Okay, we have the overall thickness, which is basically the sum of these components, the sum of these thicknesses here, with our two-course face, our cavity, a vertically cored internal, and plaster. Now, very important concept here, these names are also the recipe names in Truth Engine. So when we create quants, that will be the recipe it creates. So produce metre squared of two-course face, metre squared two-course cavity, metre squared of vertically cored internal, and metre squared of plaster. Now, if that component had other settings like sending long reach, which these two do, it will send long reach if required. So if the course height of that component is an odd course height, it will send long reach. Again, quite a simple concept. Okay, now to change the individual component heights, you can see we have these top and bottom settings against each component. So you can see this two-course face has been dropped down, which is negative 257 from the top of the wall, and dropped down 2 courses, negative 172 from the bottom. So we can double click on that, change that top offset to 0, and OK. Now if we go back to look at that wall in 3D, there we go. So now we can do something similar for the plaster. For example, if we want to reduce that plaster by 3 courses on the inside, you can select the wall again, go to Components, double click on plaster, and we'll drop the top of it, 3 courses. There you have it. So you can see with the combination of your wall styles and being able to control the heights of each component, we can model up any house. Now, one thing you might have noticed is, as compared to the objects, we had a show quants option. Now on walls, I can't do that as it is an inbuilt object. So if you want to see the quantities of a wall in isolation, this is where you jump across to use the create quants tool and just create the quants on screen instead of creating a CSV file, which is a concept we'll get to later on. Okay, so once the wall is selected, we can go to Truth Engine, create quants file. Now you'll get this prompt here. So if you say no, it will create a CSV file, which can be loaded up into Truth Engine, which again I'll talk about in a later video. Or we can view the quants on screen by going yes and previewing it. And there are the quants of that wall. So you can see there's the actual name of the style. Then we get 9.119 meters squared of two-course face. We get the surface as well for brickland. We've got the cavity. So you can see that's a different area because it is actually smaller than the overall two-course face. We have vertically cored internal, 8.509 meters squared. Plaster on the inside, 7.598, and that's quite a bit lower because it's dropped down 3 courses. And then we also send plaster paint, which is the same area as the plaster. Okay, so that wall has even coursing everywhere. So if I change that to be higher, you can see what the quants are now. And to rerun a tool that you just used, you can right mouse click and go repeat the last tool from just off the top of your screen. But I obviously need to repeat TE create quants file, so I run that again and go yes. And now because it's an odd course, those components are odd course, it's starting to send one course blocks. So we'll send linear meters of blocks to the 2 course face, and also 1 course blocks to the vertically chorded internal wall. And you see what it does now is it puts in the 1 course blocks and then takes out the meter squared component. So that's 1 row of blocks, but it takes out the meter squared equivalent, so negative 0.305. So you still end up with the same area of brickwork, but now it's built up with different brick types. Okay, so some other things to discuss with some of these wall types. So if I go and edit that, you right mouse click and go edit, select the wall again by pressing X. I'll go down to locate wall style and resource manager. Just have a look at some of these walls. So some of the things I'll mention, that all of these external brickwork walls, so your T-course face, that face always by default drops down -2 courses down to the footing every wall. But for walls like this one here, the 2 course / plaster, because that 2 course face goes down to the footing, but we don't want the plaster to go down the footing, so that stops at 0. So if we go right mouse click and edit, and we'll look at the top and the bottom. You can see that the face is set to automatically go down to the footing at -2 courses, but the plaster stays at 0. And so just as a general note, all of the wall styles will be created all that to have that consideration. So all of your face brickwork is assumed to go down to your footing, and that includes your rendered wall. So there is actually a vertically chord external that will go down -2 to your footings, but the vertically chord internal will stay at 0 at the bottom. So if we look at this wall again, we'll go edit. That's our stock standard wall that we use. Again, you'll see that basically the same concept applies. Your external face goes down to the footing, whereas your internal wall matches your 0 up to your ceiling height. Okay, and one last comment on drawing walls. If we go back to our plan view, I like to go back to a plan view by pressing or dropping down the view list and then going top plan. And we'll draw another wall. I'll draw an internal standard wall, which is our wall 90 plaster vertically chord wall plaster, a wall that we use quite a lot. And when we draw these walls, we have some options. We have the side, and this is all based on, we like to draw based on the core of the wall, which I'll show you in a minute. So that's down the left-hand side of the line you draw, or the right-hand side, and then also control whether it's the outside of the wall or the core. So you ought to notice that those walls, by definition, some of these components defined as cores. So in this wall, the core is defined as the vertical chord internal, and also the same with this wall. So generally, we will try and use this function here, which is draw down the core. Now if I draw a wall, and look at that preview, you see that the cursor is actually on the inside of the plaster and the outside of the vertically chord external wall. So that's what I mean by the core. We'll double click to finish, and there's our internal wall. Just quickly go to 3D. I like to go to 3D by holding down Control and holding down the wheel mouse and starting to move. Yeah. So this wall, you can see plaster on both sides and a vertically cored internal brickwork. And again, we can have a look at the quants of this wall. So bring up our preview. Much simpler wall. So we have plaster on both sides, paint on both sides, and there's our actual brickwork. 1.72 meters squared of vertically cored internal brickwork. Okay, so that's the basics of how walls work. When we actually start drawing some walls in this model, we'll go into all of the details and all the tricks that you need to know about how to model up this particular house. Lots of, in this case, for example, we've got, it's always a bit fiddly around the garages, so just need to know what you need to do to get the brickwork model correctly. We've got changes in ceiling height to the back here. We've got a wall with no eaves, and we have a feature wall to the front. So I'll show you how to model all of those. See you in the next video.